Let you do it. Okay, first again, thank you, Andrew. It's a pleasure to again be part of the annual State of the Energy Industry Forum. Today I'll be talking about the contributions that methanol can offer to the transition to a low carbon economy. Now, originally formed in 1989 in Washington, the Methanol Institute now serves as the trade association for the global methanol industry. From our offices here and in Washington, here and in Singapore, Beijing, Brussels, and Delhi. Our members are the world's leading methanol producers, distributors, and technology companies. And our newest members are producing methanol from a wide range of renewable feedstocks and introducing technologies to use methanol as a fuel. Now, globally, 100 million metric tons of methanol was produced and consumed last year, or about 33 billion gallons. Most methanol is produced from natural gas, about 1/3 from coal gasification, and less than 1% today from renewable feedstocks. 2/3 of methanol demand is for derivative chemical products and 1/3 from fuel applications. Here in the United States, we've seen a resurgence of methanol production driven by the shale gas revolution and the affordability of natural gas. Production facilities built with investments of over $1 billion, creating thousands of construction jobs and hundreds of permanent jobs. In fact, as we speak, Koch Methanol's YCI Methanol 1 plant is starting up production in Louisiana. The late Nobel Prize laureate and USC professor George Olah first introduced the concept of the methanol economy, using methanol in cars, trucks, buses, ships, heat, and chemical markets. We can see elements of the methanol economy around the world today. Right now, 27,000 taxis are running on neat methanol, or M100, in 2 cities in China. China's Geely Automotive Group has introduced trucks, buses, all running on methanol. A hydrogen carrier fuel in Denmark, methanol fuel cells are being used to make electric vehicle platforms practical, extending EV range from 300 kilometers to 1,000 kilometers on a simple 3-minute fill-up of liquid methanol. A dozen 50,000 deadweight ton chemical tankers are now hauling methanol around the world while using that methanol as a fuel for their ships. Methanol is one of the world's most widely distributed chemical commodities. Ferries, tugboats, crew transfer vessels could all run on methanol as a marine fuel.
Gregory, in China, I'm sorry to interrupt. It looks like your slides aren't advancing for us. I'm not sure if you're having trouble with that. Perhaps Dominic could pull them up, but we're still.
I can see them, but okay.
Dominic, would you be able to pull them up for Gregory? And then Gregory, if you'll just let Dominic know, he'll advance the slides for you so we don't miss out on your content.
Okay.
Let me try. 1 sec.
All right. Sorry, it looked like it was working on my end. Yeah, you can go a little bit further. One more. Yep, great, thank you. Thanks, Dominic. Sorry that wasn't working. As I was saying, in China, we're actually using methanol to fuel cook stoves, industrial boilers, kilns, and for home heating. Now, in a circular economy, methanol can be a chemical building block for hundreds of products, providing cross-sector reductions of the carbon footprint of paints, plastics, resins, car parts, and building materials. Next slide. Now, yesterday, the Methanol Institute released a joint report with the Renewable Energy Agency on Innovation Outlook Renewable Methanol. This is the first comprehensive assessment of renewable methanol, finding that by 2050, world demand for methanol might increase by 5-fold to 500 million metric tons. These days, of course, we like to color code our fuels. For methanol production, at one end, we have coal-based methanol, which is pretty much exclusive to China and can be considered brown methanol. Conventional natural gas-based methanol is gray. Blue or low carbon methanol will be based on natural gas feedstock with the addition of renewable electricity or green hydrogen and possibly CO2 captured from a neighboring industrial facility to reduce overall carbon footprint. Green methanol can be biomethanol produced from biomass gasification or biogas. Green methanol can also be made from green hydrogen produced from renewable electricity through electrolysis, plus CO2 from industrial sources or direct air capture. This is also referred to as e-methanol, which is also known as an electrofuel, an e-fuel, a synthetic fuel, or a power-to-X fuel. Often these two green methanol pathways, biomethanol and e-methanol, are referred to broadly as renewable methanol. Next slide, please. Now, globally, and here in the United States, most methanol is produced from the steam reformation of natural gas. Mature technology with plants that produce 5,000 tons of methanol per day, which is 1.7 million tons of methanol per year, or 566 million gallons. Natural gas is first reformed as synthesis gas, a mixture of hydrogen, carbon monoxide, and carbon dioxide, then catalytic reacted to produce crude methanol, with a final distillation step to remove water and produce methanol at a purity of 99.85%. Now, the carbon intensity of methanol production from natural gas can be reduced in several ways. CO2 can be recovered from the reformer and re-injected into the synthesis reactor, which Qatar Fuel Additives Company is doing today, or CO2 can be brought in from a neighboring facility, as Methanex is doing in Canada. Low carbon or blue methanol can also include the addition of green hydrogen, as Baofeng Energy is building in China, and Advanced Chemical Technologies is planning in Canada today. Next slide, please. Again, as yesterday's joint report we released with ARENA highlights, green or renewable methanol can be used to broadly categorize both biomethanol and process steps. First up, fossil natural gas can be replaced with biogas or biomethane from anaerobic digestion of municipal wastewater or dairy farm waste, or from landfill gas. Companies like OCI in Beaumont, Texas, BioMCN in the Netherlands, and BASF in Germany use biomethanol or biogas as a feedstock, with certification procedures to properly account for greenhouse gas emission reductions of 50% or more. Next slide, please. Now, the technologies to produce methanol from biomass or waste gasification are relatively well known, with essentially the same technology used in commercial gasification-based industries. The difference here is the feedstock preparation of biomass material, solids that need to be homogenized in some way before being fed to the gasifier. The gasifier itself is a high-temperature converter of this feedstock into synthesis gas, followed by conventional methanol production routes. Enerchem has been converting municipal solid waste to methanol and ethanol in Edmonton, Canada for several years, and is preparing to ramp up from 30,000 tons per year of alcohol production to 200,000 tons per year of biomethanol at plants in Canada, the Netherlands, and in Spain. Next slide, please. Now, in October, I had the pleasure of virtually participating in the official opening of the Södra biomethanol plant in Sweden, along with the country's Minister for Enterprise. Södra produces what they call liquid forest biomethanol from crude methanol recovered from the manufacturing process at their pulp mill. Think wood alcohol. The product is then used as a feedstock for fossil-free biodiesel fuel in Denmark. Globally, more than 300 pulp and paper mills have the potential to produce as much as 1 billion gallons of biomethanol a year, with much of that potential here in North America. Next slide, please. Now, e-methanol is a liquid product easily obtainable from CO2 and green hydrogen through a catalytic process. Green hydrogen is made through electrolysis of water using renewable electricity. To get the components of synthesis gas, we need to add CO2, which can come from unavoidable sources such as cement factories and steel mills, or from emerging direct air capture technologies. From here, we just go back to the mature processes for methanol production. The first commercial CO2 to methanol recycling plant using locally available cheap geothermal power has been in operation in Iceland by Carbon Recycling International since 2011. Last fall, I also participated in a virtual opening of the Dalian Institute of Chemical Physics e-methanol plant in China. This is the first plant to produce e-methanol from solar power on an industrial scale. As identified in our report with ARENA, other e-methanol commercial plants are being planned around the world, which if brought to fruition, would produce in excess of 700,000 tons of e-methanol per year. Next slide, please. Our joint report with ARENA also provides intricate assessments of the cost of renewable methanol production today and where it's heading in the near future. Last week, spot methanol price in the US Gulf Coast stood at $350 per metric ton, or towards the high end of the light green portion of the bar shown here for current fossil methanol pricing. I would note that fossil-based methanol is already competitive with most petroleum oil-based fuels on an energy content basis. Depending on feedstock costs, some biogas and biomass processes are economically competitive today with conventional methanol. Where we can expect to see dramatic cost reductions in line with expectations for more affordable green hydrogen is in the future production costs of e-methanol. The report finds production costs of renewable methanol by 2050 are within the range of current fossil methanol and petroleum-based fuels. Next slide, please. The various pathways provide significant greenhouse gas emission savings on a well-to-wheel basis, or in the case of shipping, on a well-to-wake basis. To date, much of the focus on renewable methanol has been in Europe, where there are policies in place and now being strengthened to encourage the production and use of renewable biofuels and e-fuels. In fact, one of the largest purchasers of biogas in the United States is our member OCI, which converts this biogas to biomethanol in Texas, but then has to ship their product to Europe, where it ends up blended in gasoline and sold at pumps across UK as an advanced second-generation biofuel. What's needed now is policies to develop markets for low carbon and net neutral fuels here in this country. Next slide, please. And methanol is a practical alternative fuel and chemical building block for often hard to address sectors. Many feedstocks, sustainable, affordable, liquid, easy to store, distribute, and use. As we transition to a low carbon society, we believe these advantages will be more widely appreciated. The release of yesterday's joint report with ARENA is a huge step forward in telling this story. So how do we facilitate this transition and demonstrate that renewable methanol can be commercially viable? First, we need to acknowledge the contributions that renewable methanol offers. And second, we need to create level playing fields. Don't pick winners and losers while the game is still in the first quarter. The challenges are so great that we need an all of the above approach. And as a low carbon and net carbon neutral fuel, methanol can help. And then with the last slide, I've just got a listing of our global contacts. And with that, let me again offer my thanks to the U.S. Energy Association for the opportunity to join with you today. Thank you.